Greetings, team. My name is Linda Stole. I am a Group 3 member, and I'm going to start my presentation on bare metal savers and end on business continuity planning. Without wasting much time, let me scroll down to where I am supposed to start my presentation. So, we are on bare metal savers. Bare metal saver is a physical saver dedicated to a single tenant. These are savers we commonly see in company saver rooms on their premises. And the companies have full ownership of the hardware and the softwares that are installed on these servers. They don't share the servers with any other company. They are the sole owners of the servers and the softwares that are installed on these servers. The server's tenant can optimize the server according to its needs for performance, security, and reliability. That is, if the owner of these servers decide that they need to improve on to increase on memory or to increase on storage space, they can just do that at their own will without consulting any third-party cloud service provider, because they are the owners of the servers. So they just proceed as they desire. This is a picture of a bare metal server, which is inside the rack, inside the cabinet, and probably inside the server room at an organization's premise. As a business, a company can have bare metal servers in their server room on premise and another set of servers at a co-location center, which replicates the servers that are on premise. Alternatively, they can choose not to have this scenario of owning physical servers on site and at a co-location center. They can just decide to rent the server hardware from a managed service provider. What they simply do is just to install their applications on the managed service provider's hardware. Then they run their applications from the service provider's hardware. The examples of industries that rely on bare metal servers, these include banking and financial service industry, healthcare, government, and basically most high intensity workloads organizations such as business intelligence or database applications. These they prefer on-premise bare metal servers due to the issue of full control of the services. If services are hosted on cloud, the owners of the information do not have full control of the information. Full control lies with cloud service providers. So in the event of governments and healthcare and the banking and the financial services, they require full control of their services and information. So that's why they prefer to have bare metal services as compared to cloud or virtual servers. And now we move on to virtual servers. A virtual server allows for the opportunity to house many clients on the same server. This is made possible through the use of virtualization software like a hypervisor. So with virtual servers, we have a single server that can have as many tenants as possible. These many tenants are made possible by the use of a hypervisor. A hypervisor is a virtualization software. So what the cloud service provider does is if an organization approaches them and requests for server spaces, they just create a virtual machine or a virtual server for that particular organization and issue and install the applications or the softwares that they require, and then they give them the access to the server through their virtual machine. At its core, the hypervisor is the host or operating system. Server virtualization allows for a much denser deployment at the cost of the overhead and limited ability to leverage all hardware features. With virtual servers, if a tenant wishes to increase on hardware space or on memory, they can just consult the cloud service provider, and then they pay for the upgrade, and then they are allocated as per their request. They don't have full control of the hardware. Full control of the hardware lies with the cloud service provider. The differences between bare metal servers and virtual servers. This pictorial representation shows the difference at a glance. As in the cloud servers or virtual servers are multi-tenants, as shown by the many tenants on it, and then the bare metal servers, it's a single tenant server. And then the differences on this table, based on architecture, on server dedication, and hypervisor provisioning, where on bare metal server, the tenant is single, and on virtual, it's a multi-tenant. And then on bare metal server, there is no hypervisor, since software or operating systems are installed directly on the hardware. And on virtual servers, there's a hypervisor, which is a software that creates virtual machines for the different tenants on the virtual server on the cloud. That's about the difference between bare metal server and virtual server. And then we move on to the other aspect on redundancy in cloud computing. In this section, we are going to explore on the importance of redundancy in cloud computing. You find that in most IT operations, the breakdowns that we face, some of them are caused by natural disasters, by power outages, by sabotage, or some by human errors. So there is need for redundancy, which is a duplication of our data, so that in the event of a failure, an organization have a fallback where they can get their data without completely losing it, and then business can continue as normal, as if nothing happened. So that's the most important way why redundancy is important in cloud computing. You find that as a business, we need to have a continuous customer experience which is excellent all the time. even in the event of a power outage, even if in the event of natural disasters, customers need to have a client experience which is as excellent as possible at all times. So with redundancy, if one system goes down, another system or an alternate or a redundant system should kickstart and continue with the business as if nothing happened. We also need redundancy because we don't need to lose our data. So in the event that an active node is a failure, we should always get our data, an alternative way of retrieving or getting our data from a redundant alternative. So that's why redundancy is important in cloud computing. We don't need to lose our data, and we need to have a continued client experience. That is, business should continue in whatever situation that may have halted the business. So, in order to make sure that we have continued excellent client experience and that we have our data, businesses should be sure to look at the following key areas. That is high availability, business continuity planning, hardware level redundancy, process redundancy, network redundancy, geographic redundancy, and storage redundancy. High availability. On high availability, this is a concept which emphasizes on systems being always up, no matter what situation the systems find itself in. System should always be up and offer client experience which is as normal as possible. And we have basic elements of high availability, which are redundancy, monitoring, and failover. Redundancy, like we said earlier, we need to ensure that any elements critical to system operations, you have an additional or redundant component that can take over in the case of failure. So as an organization, we should not have a single end, a single way of saying our system just runs like this. If it's networks, if it's hardware, we should have as many redundant hardware or many redundant networks that will take over in the event of a failure, so that the end customer does not feel of any glitch that we would have experienced as an organization. Remember, when businesses start, their main goal is to make as much profit as possible. So if we spend much time with the system downtime, it means the organization will have financial losses. So we should try to avoid that at all costs by having redundant systems. And then monitoring. Monitoring is the collection of data from a running system and detecting when a component fails or stops responding. We should have, as an organization, we should have systems that monitors that this active system is still running, and if it has stopped running, then we should shift to the redundant system so that operations continue normally. And then failover is a mechanism that can switch automatically from the currently active component to a redundant component if monitoring shows a failover of the active components. So we should have mechanisms that automatically switches when a system is down, and then switches to the one that is available. And then we have technical components enabling high availability, that is data backup and recovery, load balancing and clustering. Data backup and recovery, a system that automatically backs up data to a secondary location and recovers back to the source. This can be used to set up redundancy and failover, like we have been always saying before. We should have backup and recovery systems that backs up data and then recovers it back to the source in order to enable continuous flow of business. And then load balancing. A load balancer manages traffic, routing it between more than one system that can save that traffic. The load balancer can be aware that one of the target systems has failed and redirect traffic to another available system, thus implementing monitoring and failover. This picture shows a load balancing architecture whereby APP01 and APP02 are replicating each other. So in the event that APP01 has failed, the load balancer just redirects traffic to APP02 and probably to APP03 so that the end user there does not feel that there is a technical glitch in the system. Business should just flow normally because of the replication of these servers. And also we have another component called clustering. A cluster contains several nodes that serve a similar purpose, and users typically access and view the entire cluster as one unit. Each node in the cluster can potentially fail over to another node if failure occurs. By setting up replication within the cluster, you can create redundancy between cluster nodes. In this picture, we can see that we have a cluster of load balances. They are doing the same thing, all of them, within that cluster, such that if one node fails, the end user that does not feel it, they just the passive load balancer will activate, and then business continues as normal. So that's on high availability. And then we move on to business continuity planning. Business continuity planning, it is another aspect of redundancy, which ensures that business should continue in the event of a failover. Business should not stop just because we have faced a catastrophe, we have faced a major downtime. As businesses, they should plan ahead of a catastrophe, that in the event that we face a catastrophe, what will happen, so that we continue saving our customers, so that we continue making profit. That plan should be made way before the catastrophe happens. The process of business continuity starts with identifying various risks, threats, and vulnerabilities, and establish priorities. Then after that, you take the input from the business prioritization and perform an overall business continuity program design, then manage what has been assessed and designed. This is clearly summarized by the diagram, which is below the business continuity planning process. So here we are seeing the identification of risks, noting the impacts of the outage, and noting the recovery time objective, that is the minimum time the downtime should be before the system kickstarts, the key system kickstarts, and then the RPO, that is the recovery point objective. At each moment during our operations, we should have constant backups, so that when we recover, when we refer to the backup site, we have at least we would not have lost a lot of data, because data would have been backed up. And then we, after business prioritization, there's integration into IT, that is performing an overall business continuity program design. This is the design of the business continuity, that is process and procedures, crisis team, business resumption, high availability, disaster recovery. All this we are planning for business continuity. And then IT strategy design, high availability servers, data replication, database and software design. And then after we have designed the business continuity, then we implement it. Business continuity should not just is not meant for solving the issue that is at hand, but it should aim at establishing resilient business, that is a business that that withstand any form of outage at any given point. So this is the business continuity planning process. And then after we have developed the resilient program, you create awareness, regular validation, change management, and quarterly management meetings to ensure a continuous use of the business planning process. Basically, this is all I have on my presentation. I will leave this time to the next presenter, who will touch on hardware level redundancy up to the end. Thank you.